This screencast reviews the t-distribution. You may recall that a t-distribution has a single parameter called degrees of freedom. This is a graph of the t-distribution with 28 degrees of freedom. As the degrees of freedom change, the graph of the t-distribution changes slightly. As the degrees of freedom get larger and larger, the graph of the t-distribution becomes more and more like the graph of the standard normal distribution. The total area under any probability distribution is always 1. The t-distribution is symmetric about 0 for all degrees of freedom, just like the standard normal distribution. The t-distribution is a bit more dispersed than the standard normal distribution, and probabilities associated with any t-distribution can be read right off of the t-table. Each row in a t-table is about a different t-distribution, a t-distribution with a specific number of degrees of freedom. Here is the 28 degrees of freedom row. What we get from this 28 degrees of freedom row is, to the right of the t-value 0.6834 is a probability of 0.25. So up here in this picture, the t-value would be 0.6834, and the purple area to the right of it would be 0.25. Going a little further down that 28 degrees of freedom row, we would say, oh, let's pick a value here of 2.0484. To the right of the t value, 2.0484, so this t value here would be the 2.0484. To the right of that value would be a probability of 0.025. So there would be 0.025 area indicated by that. I think that's a purple color. So let's go over one of these problems up here. I won't pull down the text boxes, I'll let you do that. And under the text boxes are also Excel commands to get the quantities we're looking for. And those Excel commands will get the quantities to a greater degree of accuracy than what we can pick up off the table. The first problem. Shade the area identified with the probability of the absolute value of t being greater than or equal to 2.50. And of course, absolute value means that t could be more negative than minus 2.50. So to begin with, we'll shade the area in question. If this was plus 2.50, we would have to shade the area to the right of 2.50 under the t-distribution. And then we'd have to go down here, because this is two tails because of the absolute value, to minus 2.50 and shade the area to the left of minus 2.50 under the curve. The problem then asks you to use the t-table to estimate the probability in question here, the probability of the absolute value of t being bigger than or equal to 2.50. Here's our plan. We're going to look at the table and find in the 28 degree of freedom row a number as close to 2.50 as we can find, and then we can look up to the top row and see what the area is to the right of it. Please ignore those numbers that are popping up there. So let's see. 28 degree of freedom row, a number as close as possible to 2.50. Now we could interpolate, but that's more work than we're going to do for this problem. Here's a number as close as possible to 2.50, 2.4671. And if we go up to here, we see that to the right of 2.4671, we have an area of 0.01. So since the probability that we're looking for is the probability to the right of 2.50 and the probability to the left of minus 2.50, we'll just have to double this probability, that is the 0.01 probability, and we can estimate the probability of the absolute value of t being greater than or equal to 2.50 as 0.02, twice 0.01. Okay, I'll let you look further under this text box, look at the Excel commands to get these numbers more precisely. This problem is somewhat different. It actually uses the t-table in the opposite direction, and there's also an Excel command down here. So we'll end the review of the t-distribution at this point. There's also a review document on the website on t-distribution reviews, which have a few more problems.